You can see my slides okay, Kathleen?
Yes, Ken. We are showing up and we are live, and we're just going to give people another minute or so to enter the webinar and we'll get started. Well, welcome everyone, and thank you for coming today to one of our regular community circular economy for labs community of practice forums. Today we're going to focus on freezers, and we're doing this in conjunction with My Green Lab. So welcome to Christina Griever-Wilson, who's going to be moderating. But before we get started, I just wanted to remind everybody what the circular economy for labs is. We are an online community that everyone is welcome to join. It's free of charge. You don't even have to join. You can just go check it out at circulareconomy.I2SL.org. And we focus on all kinds of issues related to the circular economy as they affect things that affect laboratories, from sustainable procurement, buying less or shipping things with less impact on the environment, and then diverting wastes that occur, and addressing other issues related to efficiency and saving resources, including, as we'll hear today, freezers and other cold storage issues. So please feel free to go to the interactive site. There's a place where you can post questions for other folks to answer. There's a library you can peruse. There are videos, including recordings of other forums where this will be posted as well when we're finished. And then we do try to have, as often as we can, these forums where we coordinate between suppliers and users and talk about some of the issues affecting circular economy topics and labs. And as I said, we post the recordings afterward, and we will continue to have these moving forward. We'll talk about our next topic. You'll be hearing about it soon. We haven't posted that yet. But before we move into this, let me turn it over to Christina Griever-Wilson to talk about what we're going to hear today. Thanks, Christina.
Thank you so much, Kathleen. Happy to be here. Well, welcome everyone to the Freezer Forum. Here's a bit of a roadmap of where we're going today. Kathleen set us up with what the I2SL Community of Practice is, and I'm going to be talking about some ground rules in a second and what you can expect. And then we're going to hear 3 wonderful presentations from our colleagues, Phil Pipitone, Leoncio Lagarde, and Emily Colpack. And all of these pertain to freezers and cold storage in laboratories in different ways. And given that the International Laboratory Freezer Challenge wrapped up in July, and the winners were just announced yesterday in the My Green Lab newsletter, and will be going out in the I2SL newsletter very soon and posted all over the website. You know, it's a time for freezers, and we're going to be celebrating the winners of the 2024 Freezer Challenge coming up in September as well. So we're going to hear these great presentations on the topic of cold storage. Please, if you have questions for any of our speakers, please pop those into the Q&A function on Zoom. And we're going to hold all questions to the end and have more of a discussion. And that will be an opportunity for some audience participation if people want to unmute themselves and ask questions that way, or you can just use the Q&A feature. So right now, all of your microphones are muted to avoid background noise. So again, use the Q&A box to submit questions to any of the 3 speakers. If you want to be specific about who the question is for, that's great. Or it can be just a general question to any of the 3 presentation speakers we have today. And in the discussion at the end, hopefully we'll focus on solutions, questions you all have for these speakers, and any lessons learned from your organization and how cold storage is approached at your research organization. So I want to make you aware of a couple upcoming events in the Green Labs community. The first, of course, is the International Institute for Sustainable Laboratories annual conference, which this year is in St. Louis, Missouri. And the three talks you're about to hear are very representative of the types of talks you would hear at the I2SL conference. There's presentations that are pertaining to greening laboratories and lab sustainability, also the designing and building and engineering and commissioning of sustainable laboratory buildings. So please join us in St. Louis if you feel inclined. We will be there with I2SL. We will do the Freezer Challenge Awards there for all the organization winners of the competition this year. Very much looking forward to the conference. So feel free to check out the website to learn more. And then another event to make you aware of is the annual My Green Lab Summit, which is also coming up in September, just a few weeks before the I2SL conference. This will be spread over 2 days this year, over September 18th and 19th. It is a free virtual summit. It's free for academia, nonprofit folks, people in government labs, anyone in the public sector. And then it's just $25 a person for those in the private sector who would like to join us. So split over 2 days, hopefully at a more convenient time for those in Europe, especially at the end of your day. And you can look at the agenda online. We've got some great speakers lined up. So please join us at either or both the My Green Lab Summit and the I2SL conference. And these are just the keynote speakers that we have for the My Green Lab Summit. Dr. Britt Way, who's with Stanford, and Gary Cohen with Healthcare Without Harm. All right, so freezers. Let's get rolling with the Freezer Forum. And I'd like to introduce our first speaker, who is Phil Pipitone. And I'm going to read Phil's bio now, and he's going to get his slides up and running. So Phil is a senior life sciences manager at Energy Solutions, and Phil fosters thriving business relationships with lab equipment suppliers to develop new incentive programs, leveraging his industry expertise on life sciences equipment and its market to drive lab sustainability. And he's a My Green Lab ambassador and part of the leadership of I2SL's New York chapter. So thanks so much, Phil, for being here. Really look forward to your presentation.
Thank you, Christina. It's great to be here. I appreciate being a part of this. I think probably one of the questions we all have in mind, or already may already know, if we're here looking at freezers as a function of lab sustainability. Why are freezers such a hot topic for lab sustainability? Well, first of all, they are very energy intensive, right? They use a massive amount of energy, especially minus 80s. There's a lot of heat that needs to be pulled out of the chamber for each device to reach the target set point of minus 80 C. So it's just a little bit warmer than the coldest place on Earth, which is the East Antarctic Plateau at a brisk minus 98 C, pictured here. Also, this is a piece of lab equipment that is running 24/7, ideally anyway. That is the goal is 100% uptime on those. Typically, a uniform and stable temperature is essential for the samples that are being stored in your ULTs, your lab grade freezers, your lab refrigerators. We don't want to see spikes. We don't want to see warm spots. And that also contributes to the amount of energy that they need in order to keep that temperature internally very consistent, especially with your minus 20s, your minus 30s, where you're storing pharmaceuticals or blood samples or plasma that are highly regulated. And of course, there's continually a growing need for sample storage, especially ever since the pandemic, especially where mail-in testing became a thing. There have been a lot of sites popping up to do long-term research specifically on positive test samples. So there has been a lot of growing need for sample storage across the life sciences industry. That's in addition to all the research being done in other areas. So essentially, we're looking for something that's uniform, that's reliable. Historically, energy efficient hasn't always been the biggest priority, right? You're looking for your 100% uptime. You're looking for your samples to be safe. Most labs typically aren't paying their energy bills, or there's usually someone else at the organization is responsible for that. So when you're looking for your lab cold storage, it's typically a lower priority. And oftentimes the question comes up, when a lab is shopping for an energy efficient, I'm sorry, when shopping for a lab for cold storage, they ask, are they looking for reliability or are they looking for energy efficiency? And I always say, is it too much to ask for both? And that's one of the great things is where the industry has been heading, thanks largely to the Energy Star standards for lab cold storage that dropped in 2017. They established a baseline and a standard for energy efficient lab cold storage, essentially defining what a more sustainable product would look like. In addition, they also set thresholds for temperature uniformity to denote, what would be a high performance model for a lab grade freezer or refrigerator. And this encouraged a tremendous amount of innovation in lab cold storage. And of course, 2017, that feels like a lifetime ago by now. So there's some great news that they are actually working on some revised cold storage criteria that's coming in 2025 to focus on what the most energy efficient models are. And it's going to actually better align those high performance criteria with NSF and ANSI standards that, are essentially what you need for to meet the regulations for storage of blood, for storage of plasma, for storage of your pharmaceuticals. And this comes to a few different types of technologies that have been responsible for advancing energy efficiency in lab cold storage. We have variable speed compressors that can ramp up or ramp down depending on what the needs are of the device in order to achieve the target temperature. This provides a much more stable and consistent temperature, as well as reducing the amount of energy used overall. Also, alternative technologies like a Stirling engine as opposed to a traditional compressor. And also, use of new refrigerants such as hydrocarbon refrigerants that, not only work with a more efficient cooling process, but also, have a lower total environmental impact and a lower greenhouse impact. And then, of course, we have lower tech advancements, but are still significant. Little things like having vacuum insulated panels as opposed to simply spray foam, improving door gaskets to make them seal better, less prone to leaking, improved door handles to, again, have the same effect. And at the end of the day, what does this lower energy consumption mean for you and for your lab? Well, it means you're more able to hit your green lab targets. So you're having overall lower energy impact, which means a lower carbon impact. You're seeing lower operating costs. So for those of you who are more focused on what the organization overall is doing, as opposed to an individual lab that, like I said, typically doesn't ever see an energy bill as an end user. And then, of course, we have a less plug load, but that also typically translates to less waste heat when you don't have excess energy that's just being wasted as heat being kicked out to the room, which means you're also saving on the HVAC side, both in terms of energy and in operating costs. But of course, there are always some challenges to making any kind of upgrades or changes in the lab. And that's something that my colleagues are going to be delving into a little more in the real world application for some of these. But the biggest one typically is the upfront cost. You may be asking to upgrade your ULT when you have a perfectly functioning one in the lab. Unfortunately, that perfectly functioning model, may be getting up there in age. And as these units age, they do typically see a reduction in energy efficiency. That's why, we see some of these older models hitting 25. Sometimes, we see devices that may be, 2 decades or more old, where they may have started out using the same amount of energy as your standard American family at 25 kilowatt hours per day. But just due to age and lack of maintenance, may have, that may have bumped up to being close to 28, 30 kilowatt hours per day. And that is a tremendous drain on resources. So there's a few different methods we can apply here. One is overcoming that the financial objection typically to upgrading to a new ULT. And that is leveraging utility funding, right? Many utilities do offer rebates or incentives for making purchases that lower your total environmental impact. This is something called demand side management. And typically what that means for the utility is they've done the math and they've realized that it is much, much cheaper for them to encourage you all to adopt more energy efficient products than it is for them to, say, build a new power plant, right? And of course, there's also an additional impact to that, the social good of not having, an additional, the additional carbon impact of running another plant, and also avoiding things like rolling brownouts that can happen if the grid is pushed to the maximum during peak times. So this typically forks into two different types of programs. Historically, these have been largely downstream programs. What downstream means is that this is happening after your purchase, right? Typically, you'll see larger products. They'll typically involve the replacements of older models with newer ones. They do require a bit of paperwork and direct involvement with your sponsoring utility. Usually, they'll meter what you currently have installed. You'll make your purchases, do your upgrades, install the new models, and then again repeat the process, putting meters in place and looking at what the actual energy savings are, and then from that they'll calculate you a check and provide reimbursement towards the cost of purchasing those new freezers. And this is something that's been seen across different technologies. We also see it for upgrading HVAC systems, for upgrading lighting systems. And the upside of this is that this is something that's typically going to be institution-wide, or at least building by building, and you can get significant reimbursement. The con for this style, though, for downstream, is it's more labor intensive. Again, it's typically done by the institution, not the lab. So if you're an individual lab, it's much more challenging to benefit from programs like this. Or if you're grant funded and you're buying equipment from a grant, sometimes you just may not be able to work that into your accounting, getting a refund based on grant funds that were spent. And of course, these can vary from utility to utility, whether or not they offer anything like this, how much they'd be willing to reimburse you per kilowatt hours, et cetera. Then more recently, and this is what part of my job is developing these midstream programs, which are designed to be much more accessible. They're designed for everywhere from smaller labs to large institutions. They're much more proscriptive. Essentially, we've looked at what the baseline typically is for a non-energy efficient product, what the energy savings are compared to that for your typical Energy Star or more energy efficient products, and calculated what the price difference looks like, what the energy savings look like, and can essentially apply a flat rate towards the purchase of more energy efficient products. And the great thing is that this can actually be used towards retrofits or for new installations. So it's if you're decommissioning an old unit and purchasing a new one, or if you just need to expand your capacity, you want to make sure you're getting something that's more energy efficient to reduce your lab's total footprint while doing the necessary evil of expanding the equipment pool that you have. And these incentives are typically arranged with suppliers to provide a discount at the time of purchase. So you're actually seeing a reduced purchase price instead of getting a rebate post-sale and needing to put that funds up initially, right? So say instead of getting, if you're in Massachusetts, $2,000 back after your purchase, you're seeing that reduced price right off the top when you're making your purchase. So as this provides a lot of great pros, right? You're making it more accessible to all labs and organizations. You're eliminating the need for end user paperwork because that's actually being handled all on the back end between the utility and the supplier. And again, it's working just as well for your new installs as your replacement models. And of course, the con for this is, again, it can vary by utility or geography. Not every utility is going to offer a program like this, and the suppliers do need to opt in and be informed to participate. But that's the other great thing is if it's available, there's nothing that the suppliers need to do other than being signed up for the program and putting it on your quote when you're making the purchase. Here's an overview of where these midstream rebates are being implemented. Currently, they're available in California, in the Seattle region, as well as Spokane region of Washington State, as well as northern Idaho. It's available in Michigan and particularly the Detroit area of eastern Michigan, all the way out to Ann Arbor. We have it available in Wisconsin, in central New York State, as well as, of course, it is available in New England, so New Hampshire, Rhode Island, and Massachusetts. And of course, that is essentially, growing every couple of months or so as we work with different utilities and bring programs like this online. So say perhaps, you may not necessarily be in the position, even with these rebates available, to purchase a new unit. Well, regardless if you have a new unit or old unit, maintenance is something that's going to count for your lab freezers. There's some routine actions you can take to keep your freezers operating at peak efficiency. And of course, that starts with keeping your door opening short. The longer you keep your freezer door open, the more warm air is going to get in, the more you're going to see the temperature of your freezer raise. Of course, that's not great for your sample integrity. No one ever wants to see the temperature on their freezer, going all the way up to -60 if their set point's -70 or -80. And of course, this also will add to the frost buildup that you see in your unit. The more you have the door open, the more warmer, humid air from the room is going to get into your freezer. And of course, when that warm air cools down, especially all the way down to -80, it's going to form condensation. That condensation is going to form ice and snow inside your unit, which of course can have a snowball effect, quite literally, that we'll talk about, because that will contribute to things like your door frost buildup, something that you're going to see regardless as you go in and out of your freezer. And that's something that should be taken care of ideally on a weekly basis, at worst, monthly, because as you see door frost building up in your gaskets, that can impact the sealing when you're opening and closing your doors. And if it's not sealing properly, you're going to have an air leak. And what that air leak means is that you're going to get more warm, humid air from your lab into your freezer, which is going to cause more frost to build up, which is going to make that door frost worse, which is going to make your seal worse, which is going to allow more and more warm air into your freezer, which is going to make, again, your compressor have to work harder, because it's going to be running all the time to maintain temperature if it's leaking cold air and taking on warmer air, right? So by ensuring you've got your freezer is sealing properly and you're brushing away any frost that builds up, you're basically not only reducing the amount of frost that will build up long term, but you're also improving the longevity of your compressor and all the components inside your freezer. So you actually have less of a chance of freezer failure. Similarly, you're going to want to be checking your air filter monthly, ideally, at the very least, quarterly, removing any dust from it, keeping the air flowing properly. That way it's, cooling your internal components, making sure that there's, that they're not working harder than they need to, because the warmer everything around your freezer is getting, the harder it's going to have to work. It's going to be more stress on it, more energy, and again, shorten the lifespan of your freezer and put your samples at risk. Similarly, it's handle and door seals, right? We want to make sure that the door seals are clear, but of any frost or ice. But also want to just check their integrity every so often, right? At the very least yearly, but it's something that should be done, as needed, and replaced or adjusted as needed. Many suppliers or service organizations will come in and they'll adjust your handle. They'll replace your door seal if it seems like it's failing, or worn in any places, because this is where the biggest vulnerabilities are, right? It's how you completely isolate the environment inside this chamber from the outside environment that's going to be harmful to your samples. And of course, inventory management is something that's becoming more and more important, right? The more samples you have inside of your freezer, the easier it is to lose something and misplace something, right? So if you know what's inside your freezer, you can, number one, shorten your door openings because you know exactly what box it's in and what rack and what shelf it's in, that we can go in very quickly and retrieve your samples, get in and out as quickly as you can. And secondly, it reduces the impact of UFOs inside your freezer, your unidentified freezer objects, those samples that might be, that, you know, are just taking up space, that may be expired or part of some old research or something that may have just been abandoned by another researcher who had that before you. And that's of course something that, you know, is done in the freezer challenge, right? It's one of the things that are identified. A ULT freezer maintenance document shown. Thank you. That's a great question. That is actually available on the Freezer Challenge website. I can circle back and share a link to it. This is something that was, I believe, published by Eppendorf, but a few manufacturers have put out maintenance documents for freezers. And typically, those best practices, those are going to do you good regardless of what make or model of freezer you have. So I will leave it to some of my colleagues who are going to discuss their real world experiences with these and getting them implemented across larger organizations. If you have any questions about incentives that can be used to, you know, reduce the cost when you're looking to expand or upgrade and want to make sure you're purchasing a more energy efficient freezer, please, you know, feel free to reach out and connect with me. Also, you know, the people involved in this conversation, your facilities and EHS groups, sustainability and procurement. You know, this is something where you can actually talk to your procurement folks and make sure that if you're in an area that's eligible for a rebate or an incentive, that you're getting it and you're checking each quote you get from your suppliers to make sure that they're offering it to you on every sale. You can check with your utility to see if it's something that they're offering upstream or downstream. If you feel like you know, your area could benefit from a program like this, you know, please, we can always have a conversation, discuss, you know, what the market looks like in your area. If you're, you know, involved in any larger purchasing or growth plans, that's something that the utilities love to see in terms of developing a program like this, right? Because they want to see a large impact. And the more units that are going to be expanding in an area, the bigger, the more impact will be for them as well as for you. All right, thank you, everybody. I'm open for any other additional questions before we move on.
Thank you. Yeah, Phil, thanks so much for your presentation. Really appreciate hearing about those midstream rebate programs and how people can be advocates for them, as well as reaching out to get their utility companies and suppliers involved. If anyone has additional questions for Phil, feel free to pop those into the Q&A feature, and we will do more of those at the end. Thanks so much, Phil. So now I'm going to move on to our second presenter. I will introduce Leoncio while he gets his slides up. So at the University of Colorado Boulder, Leoncio takes on the role of the Green Labs Program Assistant and Outreach Coordinator. With a solid academic foundation, including an undergraduate and master's degree from the Earth and Planetary Science Department at UC Berkeley, coupled with his previous professional lab experience as a chemical analyst, he is dedicated to fostering a culture of safety and sustainability in laboratory settings at the University of Colorado Boulder. Through maintaining sustainable lab projects and facilitating targeted training sessions, he aims to propel forward impactful and sustainable practices within the campus lab community. So thanks for being here, Leoncio, and looking forward to this update on the shared freezer program.
Perfect. Thank you, Christina. Hi, everyone. As Christina mentioned, my name is Leoncio Lagarde, he, him, his pronouns. I'm the Green Labs Program Assistant and Outreach Coordinator for CU Boulder, and I'll give you a quick overview of the Green Labs Shared Ultra-Low Temperature Freezer Program at our institution. So a quick overview of the agenda. I'll be going through the introduction of the program, so really talking about our goals and our what we're trying to accomplish. Program layouts, including freezer locations and that importance. freezer users and what they have to go through and the steps and procedures. Optimize inventory, basically learning about how we at Green Labs best optimize inventory for our lab users. We'll be talking about freezer maintenance just for a little bit. Also financial incentives, specifically incentive processes. And I'll give you a small calculation for as an example. So our shared ultra-low temperature freezer program started about in 2015. We currently stand at 8 ultra-lows, but we started with 3, so it's definitely growing. Right now, we do have 42 labs throughout campus who use our shared resource. Right now, we also have 7 mobile -20 freezers, so those are just for emergencies. So if someone's ULT breaks down, or if they just need to do a clean out, they use some of our mobile freezers for about a couple of days while they get that all sorted out. I also want to give a huge shout out to our Green Lab student staff who assists us with this program and its operations. So program goals for the ULT Shared Resource Program. We were trying to promote efficient equipment sharing across campus. So really diving into the equitable access to shared resources is super crucial to our program goals. Also reducing laboratory plug loads, which ultimately saves research dollars. We also want to encourage more efficient use of freezer space. If our freezer's inventory is optimized, our freezer users can go in as quickly as possible, grab their samples, go back to the lab, ultimately saving them a lot of time and money. So we also want to contribute to the sustainability culture of CU Boulder. Right now, we're trying to implement and minimize, the environmental footprint of research taking place at CU Boulder. So perfect. Where are our freezers located? Right now, we have 2 in biotechnology building, 3 running in the ecology building, 1 in our life science building. We have another one in our Porter Biosciences, and then we recently installed one in our engineering center. So a quick map view of this. So on the left here, we see that on our East campus, we have around 2, hopefully getting 3 soon in the future. We have 1 in the engineering center, 1 in Porter Biosciences, 3 in Ramaley here located in ecology, and then 1 off campus in Wilderness Place. So ideally, we want our users to be localized to wherever their freezers and labs are located. So if you're centered in main campus, we ideally will set you up in our ultra-low temperature freezers that are on main campus, compared to if you were in the biotechnology building off on East campus, we'll set you up in some of our freezers over on East campus. So first steps. So whenever someone reaches out to us, they usually email us, or we also do some outreach engagement. So we either go to lab, or we have some flyers posted up on the TVs or in our poster holders throughout the research buildings to try to get the word out for folks to, let them know that we do have a shared resource available for them at this institution. The next step is that they have to let us know their desired freezer location. So in that map that I just showed you, they basically point out where they want their freezer space to be held. And then we hook them up with access to that building and get them situated with our program. We do require them to let us know how much space and quantity of boxes they'll be needing. So if it's a 2-inch, 3-inch, or volume, we ask that they provide an estimate of a number, so that way we can sort of organize them into a specific location within our freezers. So rental rates, essentially for internal users, that value never changes. Right now it's at 25 cents per 2-inch box. For 3-inch boxes, it's around 37 cents. And then for volume, it's 20 cents per liter. Rates have been approved by the University of Colorado Boulder's controller office. And so we do collaborate with them to get these rates. For external users, there is a separate process that needs to happen. They do have to sign off on a contract with our controller's office. Specifically, they have to go through our Office of Contracts and Grants. I quickly want to show you a rate-based calculation of how we came up with that 25-cent value. So starting from the top, our cost of a freezer is typically, if we estimate, around $12,600. And then we used a value of 600, typically 600 2-inch boxes in a standard ULT freezer for its capacity. The depreciation value, we used around 84 months, so typically around 7 years for a freezer. And so the rate we used was the cost of a freezer over the depreciation value in months times the freezer capacity. So if we want to check that, 600 times 25 cents is around $150 per month. Therefore, after 12 months, we get around 1,800 a year. So after 7 years, it's around the value of a freezer. So that's how we came up with our 25-cent value. So as I mentioned, our external users, they have to go through a contract process. This contract that I put here, it's a bit zoomed out, but all you need to know is we need to get their customer organization legal name and address and a billing contact, as well as customer technical point of contact. So our Office of Contracts and Grants handles it from there. We get their billing contact and information. We let them know who to make the checks out to. And their values, of course, as I mentioned, are a little bit higher, and those change annually. And our campus accounting officials help us with making that change for their rates for external users. So when we finally have a freezer user signed off and ready to be placed into our freezers, there are some expectations and requirements. First, specifically, we do let them know that all of our ultra-low temperature freezers operate at -70 degrees Celsius. We also have to let them know that we need at least one person to connect with to put them onto our inventory spreadsheets and then our alarm systems. Some of the also requirements are, as you see here in this image, we ask that all of our lab users that are in our freezers label their boxes. We ask them to label them with at least the name. Some folks even put phone numbers. We already have their contact information, so we just ask that they add their lab name. Some people even have added their item material, like what exactly is in the box, and that helps them identify it, and it also helps us identify some other samples too. So we also have to give them access to the building. Some of our buildings are locked, some of the rooms are locked, and then our freezers are behind those locked doors. And so we have to work with building management and or campus buff one card is what we call it for our campus ID to get them access to these buildings. If they're internal, they most likely already have a buff one card, so it's really easy to give them access to our buildings and our doors. If they're external, we have to get them a temporary visitor card, which usually is about a year long of access, just to get them into our facilities. Let me take a drink of water. So moving forward, there is also a monitor inventory spreadsheet. So essentially having access to our materials and letting them know how and where they can find their samples once it's in the freezer. So they do have a designated area, and we do ask them not to move around and just remain in their designated zones. And this inventory spreadsheet, which I'll show you in a minute, details where their samples are, how many samples they have in our freezer, and they do have comment access. So whenever they're making changes, we just ask that they update and comment on that spreadsheet, and then we'll approve it, verify by going into the freezer, and then all the inventory should be updated. There's also an Insight alarm system that we do subscribe them as well, which I'll show you in a little bit. So they're in our freezer and they are in person and they want to check out an item. We ask that they first check this schematic that is on the face of all of our ultra-low temperature freezers, our shared freezers, before opening the freezer, just to make sure that they know where to actually look at, which optimizes time when opening a freezer. So just to get an overview of this image here, so shelf 1, rack A is placed here, rack B, C, D, and E. And our schematics change depending on what kind of freezer it is, but a majority of our freezers have this 6-shelf A, B, C, D rack layout. So perfect. Something that they can do at home or in their lab is just check the inventory live. So we made this automized spreadsheet. It's a free thing that we like to use with our student staff. They update this for us, and it's really like the student aspect that brought this to life, because they worked on the small code to implement into the spreadsheet, and they frequently check for updates. So we look at column A. The equipment number is a primary identifier for all of our ultra-low temperature freezers. It's a unique identifier. So whenever we're talking about a specific freezer, we ask that the lab check that the equipment number matches on the spreadsheet. We also see lab size here on row 3, and then the box number And then the purple at the bottom is the quantity and totals of how much they have in our freezers. And then if we look at this next row, so 1 and 2, row 1 basically details the shelf number that the lab user will be in. And then the second will be the rack position. So A, B, C, D, and E. Some labs here, they've added their name, and then they've also incorporated when they added their samples into this. When they go in here and they comment, we then approve once it's been verified in person, and the totals automatically add up here at the bottom. So for spots that are vacant, we like to just see this visually. So in the future, if a lab does come up to us and asks for a specific space, or if they are expanding their quantity, we now know what space in our freezer is empty and vacant for them to then add their samples to in the future. So once we have that inventory spreadsheet, so the billing spreadsheet is something that my staff sees on our end. So lab users may have access to the billing spreadsheet if they ask for it, but this is something that we work off with our accounting folks and procurement office. So they basically go off of the inventory spreadsheet. We put the number of boxes into a quarterly rate system. So we bill them every quarter. So right now, for an example, for January, February, and March, we total up how many 2-inch, 3-inch, and then volumetric quantities they have, and we total that up. And then we do that for 3 months. And then at the end of those 3 months, the lab user gets billed. Essentially, what we need from the lab is a lab name, the classification, whether it's internal. So we charge them for internal rates, which are above here at 25 cents. The freezer location, so ideally localized to their lab. And then billing contact. So who are we going to be sending our quarterly billing to? And again, this is done on an Excel spreadsheet. That's the best way for our team, and that works for us. There are other platforms that work well for inventory or billing, but for my student staff and myself, these spreadsheets have always been very useful for us. I also wanted to talk about our inventory alarm system, which is we use Insight for. The picture's a bit blurry, but all you need to know is that all of our users are subscribed to these alarm systems. So if anything were to go awry or wrong, they are notified after a certain period. I am notified first. So if the door has been opened for 300 seconds or more, I get notified first. I then go onto this alarm system website, check to see if the temperature is looking okay. Most likely it is the door just being opened and nothing more. And so after a while, I'll check, and then the temperature has just gone back to -70. However, if there is ever an emergency, it's always important to have these alarm systems because our freezers are full of very expensive materials. And so having this alarm system is definitely a benefit for us. I won't dive too much into freezer maintenance. Just know that every month we do check our inventory for every single freezer that we have. In addition to checking inventory, we also have our student staff go in and remove ice off of our freezers. So they go in with the brush and just remove some of that ice for us. It's always important to keep track of your maintenance just because it helps ultimately with energy efficiency. Cool. I want to talk a little bit about financial incentives. I do see some questions in the chat, but I will answer them towards the end. So financial incentives, we provide financial incentives for laboratories that are interested in changing to a more energy efficient freezer. So if they have a freezer that they're trying to retire, or if it's broken, they reach out to us either because they've seen posters that we've hung up, or we've done lab-to-lab outreach. Or sometimes what we've done is that through the Insight monitoring system, I have access to all of the freezers on campus, so I can see the energy consumption of all the freezers on campus. So at times, we do reach out to labs in particular where we've seen their freezers using a lot of energy. This incentive program, I think, started around 15 years ago, essentially when our state government, specifically the energy office, was trying to do outreach to the university asking for energy intensive ULT freezers. And then they were offering us a small fee to get energy efficient freezers. The marvelous Dr. Kathy Ramirez Aguilar, who some of you may know, at that time was reaching out to labs to nominate freezers so that they can get that incentive from the state to then get ultra-low freezers that were efficient in energy. Once that happened, since that was a one-time event, Kathy then reached out to our facilities management folks, and then as well as the director of the environmental center where we work, to say, what if we just implement this financial incentive program and keep it? And success was there. So the process, basically what it looks like is we have the awareness part. So as I mentioned, they either reach out to us, labs reach out to us, or we reach out to them. The evaluation process is simple. We basically ask that the freezer that they're trying to replace or get rid of is consuming way more energy than the freezer that they're looking at purchasing. So we have to make sure that this evaluation happens before we make any then further steps onto like purchasing a new freezer for them. As well as Green Labs, we have to dispose of their old unit. And that disposal process is really lengthy. I'm hoping that it's more streamlined down in the future. That way it's like optimizing the amount of time we take to provide these incentives. However, once we get rid of their freezer, we then tell them the amount that they're going to get. We submit requests and then the incentive is applied. I do want to show you how we come up with this incentive value with the return on investment of 5 years. So for folks that love some small calculations, I have a very quick way of finding these incentive values of what we can give the labs. So for example, hypothetically, if we have a lab's old unit that is about 18 kilowatt hours per day, and they want a new freezer that is about 8 kilowatt hours per day, a value that the energy office here at our institution gave us was about 0.085 cents per kilowatt hour saved. So with a ROI of 5 years. So doing quick maths, 18 minus 8, we get 10 kilowatt hours per day saved with that new purchase. So with 10 kilowatt hours per day, multiply that by 365, we get ultimately 3,650 kilowatt hours per year in savings. So if we take that value, multiply it by the value that we were given by our energy office, we get roughly $310 a year. So with an ROI of 5 years, 5 times 310, we get a value that we can then give them as an incentive. So what are the benefits of this incentives program? Firstly, we engage with community of scientists on sustainability. So we typically like to engage with them on sustainability actions. And so this is one great way for us to kind of get the word out of like some of our practices and the benefits of being more sustainable within your lab spaces, as well as educating scientists on their overhead costs. And I wanted to put this little lengthy text here because it's really important. But we found out that this is the only program at CU Boulder that we know of, essentially, that scientists are directly connected to their indirect costs, so their overhead costs. In other words, they save energy. The scientist then gets financial incentives towards the cost of the equipment. So other than educating scientists on their overhead costs, we also talk about energy cost reduction and infrastructure costs and reduction there. And that's all I have for this presentation. If you have any questions, I think we might answer them towards the end, Christine, if that's correct.
Correct. We will do some Q&A at the end. Thank you so much, Leoncio, for that great presentation. Loved hearing about the midstream rebates in effect that are happening at CU Boulder. And then we heard about some midstream rebate programs through Energy Solutions and Phil that are more at the state level. So let's now hear from Emily Colpack at the University of Alabama at Birmingham. So Emily Colpack is the Green Labs Coordinator at the University of Alabama at Birmingham, where she has overseen the Green Labs program since 2020. Emily works with labs on reducing energy, water, and waste generation. She helped implement a robust lab recycling program and the freezer challenge at UAB. And Emily, congratulations on UAB's honorable mention in the 2024 freezer challenge.
Thank you.
Turn it over to you. Thank you.
Awesome. So all I'm going to talk about freezer maintenance. So UAB Green Labs started in 2016 as a pilot program. We have over 900 researchers part of our program today, and that also means we have about 150 labs part of our program. UAB has a lot more research labs on our campus, but inside our program, we have about 150 labs. And then on our campus, we have over 900 ULTs, and we've calculated that at minimum, they generate over 6 million kilowatt hours per year. So that's over 600 homes worth of energy. And so we like to use the freezer challenge to improve freezer maintenance on campus. Labs are a little more interested in the idea of a competition than the actual prize. We've actually given away a free ULT freezer, and the labs really did not care about the freezer. They didn't talk about the idea of winning the freezer. They really just wanted to know, how are we doing in the competition and what can we do to win? There was no, oh, what's the prize? It was really more, we want to win or beat the other lab down the hall. Of course, since it is a competition, we still need to have a prize, but I want everyone to know that the prize is not the most important part. So we use the competition to motivate labs to complete various action items. And then this also gives labs a deadline to think about. So when I give Green Lab presentations to our labs, it's very easy to tell them what to do, but there's often not really any incentive to do those action items quickly or do any of those items in a time frame that is convenient for the lab. And so if you give them a deadline of the competition ends on this day, on this month, it gives labs a deadline of, oh, we need to do this action item before the competition ends. And so we have a 2025 freezer challenge game plan, and I'm going to share it with everyone. So we're going to identify an intern to help out with the freezer challenge from January to June. We're going to train this intern on how and why we recommend various behavioral changes. And then we'll send the intern out in the wilds to all of our research labs after a few shadowing opportunities. So after the intern has seen me interact with the labs and after I have pretended to be a really difficult researcher or a really difficult lab and quizzed the intern on why they should do certain freezer challenge practices, they are then allowed to go out in the wilds and talk to our researchers. And then one thing we're going to add new this year is we're going to have the intern send a follow-up email to the lab on what they've completed in the challenge, an estimation and how much energy they saved, and recommendations on how to improve. So we haven't told our labs how much energy they're saving by doing these behavioral changes. And I think a change that would be really helpful this year is to email each lab that completed the challenge their overall score, convert it to how many homes worth of energy they saved, and then give recommendations on what they can do to improve. And so, of course, that means the intern needs to really know various cold storage best practices. We really focus on making sure they know how to clean freezer coils and filters, how they can tell the lab to defrost. So our interns will actually not defrost the freezer or chill up the freezer for the lab, but it is important that the intern knows what a defrost is, how a lab can defrost, how a lab can improve their sample inventory, how a lab can get rid of samples, and various other things that help the overall efficiency and overall, freezer cold storage program at UAB. And the intern needs to know how to describe these action items to the lab. So they can recommend these items to the lab. If the lab wants to chill up their freezer, so changing the temperature from -80 to -70, they often will reach out to me where I will go and show the lab how to change the temperature on their freezer. Now, the newer freezers are much easier to change the temperature. All you have to do is click temperature set point and you're very easily able to change it. But if you are like UAB's campus, where a majority of our freezers are really old, you do have to sometimes look up the manual and see how to change the set point of the temperature. And that's really important of knowing to do that before you get to the lab so that when you show up to the lab, the researcher all they have to do is watch you or you show them how to change the set point. And then we also provide deliverables for our intern to hand out to the research labs when they are going and cleaning filters or when they are giving freezer challenge questions. And so another really important note is making sure that intern writes down the locations they have visited, which labs they have skipped due to locked doors or an empty lab. That way you can go back to that lab later on and make sure that they are still also getting this important freezer maintenance. And so we give labs a freezer maintenance checklist. This is really important because I'll ask a lab, hey, when was the last time you defrosted your freezer? And they'll tell me, well, it was when it was hot outside. Well, in Alabama, it's hot almost every day outside. And so that is not helpful. So making sure labs are able to write down the date that they have completed certain action items helps them remember, hey, it's actually been a year since we last defrosted our freezer. It's time to defrost again. And so labs are often very reactionary to their freezer problems. I'll get a lot of emails, hey, my freezer's not working, or hey, my freezer door won't even close anymore. We need to defrost. And so we really want labs to focus on this preventative maintenance so that they are proactive in their freezer's overall health. This can help the freezer run better, it's going to be more efficient, and it's going to last longer. And so we have our little freezer maintenance checklist right here that shows, all right, the lab completed this item. When we go and clean freezer filters and coils for the labs for free, we'll actually bring a dry erase marker so that we can write down the completed date that we cleaned the freezer filters. And so you might be wondering, is it hard to clean the freezer filters? It is not. It is really easy. We have an intern right here cleaning a freezer filter. The labs really appreciate not having to schedule anything. So if you wanted to know how we do this, we literally send an intern out with a vacuum and our freezer cleaning supplies, and we just tell them go to every single lab and ask if they would like their freezer filters and coils cleaned. I continuously often get asked, when is the next time you're doing our yearly freezer maintenance cleaning? They really appreciate not having to do any kind of thought or work behind that filter cleaning. And then this is also an opportunity to find new labs and show them the benefits of green labs. So a lot of our labs around campus are very skeptical of various programs or initiatives. And so having our team be able to provide them a service immediately without them having to ask for it gives us a lot of credibility. It shows we say what we are going to do, and those labs are more likely to listen to us and trust us and do maybe these other action items. And then of course, you know, we can send out as many emails as we want, we can hang as many posters as we want, but there's signage fatigue, people don't check their emails. And so having Green Labs show up to their lab and provide these services is a really good way to get the Green Labs name out there. And then we've got a few freezer cleaning supplies. They're very inexpensive. So this is a great way to kind of start a freezer maintenance program at your university. You just need a shop vacuum with a hose attachment for easy cleaning. So if we look on that last slide, you can see our intern Sandra. She has a hose attachment and she is cleaning the filter with that attachment. It's a lot harder to have a vacuum like actual cleaner, and having that hose attachment is really important in being able to easily clean those filters and coils. And then having multiple rechargeable batteries for the vacuum. So you'd be quite surprised that the vacuum cleaner battery drains quite quickly. So if you send an intern out for a few hours, you might need a few batteries. A toothbrush. I know that sounds silly, but the toothbrush is one of the best ways to clean the freezer filter and coils without damaging the coils itself. It is the easiest way to get that dust off there. It's even better than the vacuum cleaner itself. So we have a freezer toothbrush in our office that is just for freezers. Making sure you have an extra filter. So a lot of our older freezers, that filter literally falls apart in your hands, or there's not even a filter on the freezer. And so making sure you have a filter roll where you can cut the exact size needed, you can replace falling apart filters, and this really helps catch a lot of the dust that can go inside the freezer filter and coils. And then making sure you have PPE for your freezer cleaner. So we'll buy them masks for the dust, gloves so that when they're not, they're not touching the dust, and That way we can protect our person that's cleaning the freezers. And then this is an example of a really dusty freezer. So on the left, you can see it's covered in dust. It's not going to be working as well. It's having to work a lot harder. And so all you need to do is get that freezer toothbrush and start brushing the dust off those coils. And then on the right, you can see this is an after of a freezer cleaning. So after we've done this for a few years, a lot of our freezers don't look like this, but when we first started out, a lot of our freezers looked this dirty and this dusty. And so having this freezer maintenance program where our interns just go out and clean freezer filters has been really helpful in identifying some of those problem freezers. And then these are some of the deliverables that we give to our labs. All of our Green Labs get talked to about cold storage best practices during our Green Labs presentation, and they are the ones that typically do the best on our freezer challenge. Labs that have not ever had a Green Lab presentation or don't know anything about Green Labs, this is really good for them to get some of these deliverables where they can start implementing cold storage best practices. On the left, we have boxes where they can kind of label, A1, A2, A3, and they can be really nitty-gritty on terms of what's in those sample boxes and use maybe an Excel spreadsheet along with this freezer inventory map. And then on the right, it's a little more blank. That way a lab, if they've got, they just want to label who's on what shelf, that can be helpful. This is primarily for some of our labs who don't like having an Excel spreadsheet and I like to say messy in terms of their sample inventory. This is a good first step in helping them have an idea of what's on what shelf. That way, when they open the freezer door, they know what shelf they're looking for and they're not leaving that door open for a really long time. And then we also let labs borrow some of our freezer items. We have a mallet and an ice scraper. We will not de-ice the freezer for the lab. We have videos on how to do it with the mallet and the ice scraper, but we will not do it for the lab. I tell the lab that is on them. They're allowed to borrow the mallet and the ice scraper and the brush for 2 weeks, but we will not do it for them. This is way we don't have to do a lot of this maintenance ourselves. It would take a lot of time on our part, and it would be a risk of what if something happened to the freezer while we were using the ice scraper or mallet? And so we just loan them off for the labs to use. They're very inexpensive to buy. And it was really easy to just, write our name on it and labs will just email us if they would like to borrow it. And then this is a little more expensive, but we do have what I like to call a floating freezer program. Labs are able to reserve a defrost freezer to defrost their freezer. So labs will take all of the items out of their freezer and put it in our freezer. We often recommend labs throw out old samples during this time when they're doing a defrost. And then in between uses, we do keep the freezer at -60. And whenever a lab wants to use it, we'll go and we will actually change the temperature to whatever they desire. This often is -80. While we do really recommend and push labs do -70 on our campus, only about 15% of our labs actually have their freezer set to -70. And so whenever I give a Green Lab presentation, I offer, do you want to change your freezer to -70? I often get told no for various reasons. I always push them, but because it's a voluntary program, it is up to them to have their freezer temperature at whatever they would like. I have found that younger researchers are more willing to change their freezer temperature. And what I'll do is I'll offer to show them how to change the freezer right then and there. If the lab says they're going to change it later, as much as we want to trust their good intentions, sometimes people forget. And so it's much easier and better to go with the lab at that point in time and say, okay, let's change it together. That way, if you ever need to change it back to -80 or you need to do something else with your freezer, you know how to change the temperature. And labs are often surprised how easy it is to change the freezer temperature. It's almost a little silly how little the labs check their freezer to make sure what kind of functions they have. And so if we ever have a lab that wants to have our defrost freezer at -80, they are allowed to do so. So I'll go with them, I'll show them the freezer. We do keep this freezer locked in between uses. You'd be a little surprised. One day, someone did not lock the freezer and someone had immediately put their samples in our freezer. And so we really had to work with some of the labs on the floor, making sure they knew that they couldn't just put their samples in our freezer, that it was only for defrost. And we worked with them and everyone was able to get their samples out. And then that lab actually did want to defrost, so they got to defrost their freezer. And then if you have any questions, you can feel free to email me, although of course we do have the chat function, but if you have any extra really long questions, that's my email. And then I'll give it back to Christina.
Wonderful. Thanks so much, Emily, for your presentation. Really appreciate it. Just for everyone's awareness, University of Alabama Birmingham regularly participates in the International Laboratory Freezer Challenge and has done very, very well over the years. So when Emily's talking about the freezer challenge they're running at UAB, they're leveraging the data that we provide from the International Laboratory Freezer Challenge, which is a partnership between My Green Lab and I2SL, and provide that data set to UAB and other organizations that want to do these sort of internal competitions with their own prizes, encouraging competition between the various labs at their organization. So we do that. The Freezer Challenge is a free program. Any organization that wants to do something similar to what UAB or CU Boulder is doing in that regard can absolutely do that. Well, at this point, let's have Leoncio and Phil also come back on, and we're going to do some Q&A all together. Please stick around if you have questions. Please stick around anyway. It's been great to have so many people live on this webinar today. We had almost 60 people at one point, I think, so that's been really wonderful. I know some of the questions have been answered in text form, but I feel like we should reiterate some of these for everyone. I'm not sure everyone can see the answers in the Q&A. So let's start.
That would be great if we can go over those. That would be awesome.
Perfect. So I guess let's start off with one of the questions that came in to Phil while Phil was presenting. Examples of hydrocarbon refrigerants. Phil, if you want to kind of reiterate what a hydrocarbon refrigerant is for everyone and some examples of that, that'd be great.
Sure, thank you. So hydrocarbon refrigerants tend to be more efficient as coolant, and B, typically have a lower greenhouse gas impact when end of life. The ones that are most commonly used tend to be propane and ethane, or a blend of the two, and you'll find those in freezers from a number of different manufacturers.
Mm-hmm. Great. And so like non-hydrocarbon, or I don't know, what's the alternative to hydrocarbon refrigerants that may have been more commonly put in all of these sorts of freezers, say?
Like your HFCs, your hydrocarbons, your hydrofluorocarbons, things that are no longer meeting SNAP guidelines. And I know originally there was a bit of an extension to meeting SNAP requirements that was given specifically for -80 storage, but I believe we're at the point now where either it's being phased out entirely, or just there's more of a voluntary phasing out of these among the industry. I guess they're just, regardless of life sciences getting an exception, they're still becoming more and more difficult to actually obtain, which means it also can be much more expensive.
Great. Thanks so much, Phil, for that. We'll go on to another question that came in. This was, I believe, for Leoncio. So how do researchers typically transport their samples to the shared freezers at CU Boulder?
Yeah, so what I've seen in the past is, depending on the quantity of samples that someone has, at Green Labs, we also recycle foam, like number 6, polystyrene. And so if I have an abundance of foam at our recycling sites, And if that lab is in need of some storage units for transport, I sometimes take some of that recycled foam, hand it to them put their stuff in for easy transport. That's only ever happened a few times with someone that was moving in over, I think, 400 2-inch boxes into some of our freezers, which was a project in and of itself. But I also collaborated with building management for heavy items, like for some of those boxes that contained like 100 2-inch boxes per little box. And they then provided like pulleys, like carts, essentially. So we loaded up the truck with the samples. Building manager brought the carts for us, and then we put their samples into the freezers. I've also seen folks have like chests on wheels, so like freezer chests on wheels that they've transported from building to building. Typically, environmental health and safety would like to limit the transport of like samples walking to building. So we always encourage folks to have their lab within where we keep our freezers. So if it's in the biosciences building, we then ask that either it's relatively connected to that location rather than having to walk across campus to move their samples from their lab to our freezer, which we have no issues of as of right now. There was one time when there was an emergency where we did have to transport some items from our geology building to our biosciences building. But that, of course, we use a chest freezer to move items for that. So that's essentially how it looks for our campus. But if anyone has any other, like Emily, if you have other thoughts of that, but.
Awesome. Thank you, Leoncio. Let's go to a question that came in for Emily. So Krista wrote, we have tried to offer coil cleaning, but the protest is that freezers are too full to move in order to access the coils, which are sometimes at the back, sometimes underneath. It would require defrosting at the same time, perhaps, in order to move the heavy units. So how do you get at coils that are behind heavy ultra-lows?
The answer is we often just don't. Most of our ULTs have the filters in the front if it is too difficult to access, or there are screwdrivers in place, or screws that where we would need a screwdriver. We often tell the lab if they want the freezer filters and coils cleaned that they will have to make it easier for us to access. We won't move the freezer for them. We won't clean a lot of -20s for this reason, because most of the filters and coils on the -20s are on the back of the freezer, and we don't want people moving their freezer, risk of unplugging, or the plug coming out of the wall. So we really, the answer is we try not to, because the risks, I think, outweigh the benefits of accessing those filters and coils. But I would say maybe 90% of our ULTs have the filters in the front of the freezer, where we're able to access them without having to move the freezer at all.
Nice. And presumably if a lab wanted to move their own freezer to help with the freezer maintenance themselves, they could do that.
They're allowed to do that if they would like to move it themselves, but we won't move it.
Yeah. Great. Thank you so much. Another question, I guess, to any of you, are we aware of any fire marshal permitting requirements with hydrocarbon refrigerants in these more energy efficient freezers that are on the market today? Any special requirements there, or in general, once the unit is purchased and brought onto, delivered to campus, is it all right?
I mean, none that I am aware of. I mean, the amount of flammable materials in these are measured in the micrograms, so it's a very, very small amount. To my knowledge, there haven't been any concerns or issues with these, and they've been implemented for about 4 or 5 years now in the US, and even longer in the EU.
Well, and actually, if my memory serves me, hydrocarbon refrigerants were the norm way long ago. Like, they were the original. And then it was shifted to more, I don't know, higher cooling power. And that's kind of our nastier refrigerants that were in use for a while, and now switching back to hydrocarbon options. So they've definitely been on the market for a long, long time. All right. Another question that went to Leoncio. A question about people camping out in the shared freezers. Do you ever have trouble with people staying for too long, and how do you address that?
Yeah, so for our internal users, we are typically more lenient for internal users. So folks that have speed types, which are funds, for the university. And we've never really had issues with folks staying for too long. We've had issues with people having space in our freezer and then basically ghosting us, if that's the phrase, where they kind of don't have communication. However, they're still being billed and charged. So like their money is coming in, so we don't want to remove their samples because they're still technically paying for our storage space. However, if we reach out to them saying like, hey, we're moving your samples over one rack position to make space for like this bulk item, and if we don't hear back from them after like constant communication, then we'll start to talk about like whether their things should be like removed into a temporary freezer while we find out what's going on with them. But that rarely ever happens. There was an instance, for example, for external users, since they're off on a contract, typically they're off of like 1 to 5 years, 5 years being a maximum that they can use the contract for until they have to renew their contract. If their contract expires, we then reach out to them to renew it. And if they don't renew it, like for example, if they ghost us again, then we have to talk to the building manager to essentially see if we can put their samples into another emergency freezer for time being. But we rarely ever like throw things out without folks' permission and consent. If it's like an empty box without any samples, then we'll probably just recycle that 2-inch box, for example. But what we do struggle with is people using our -20 mobile freezers, which are meant for 1 to 2 week storage for like either freezer cleanings or emergencies. We've had a we had a lab use some of our -20 mobile freezers who said, I'm requesting this for a week. And then it's been 3 years since they've returned it back. This was like pre-COVID. And then I think last year we finally ended up getting the freezer from their lab. And it happened so randomly too, because we were walking into a lab to like ask if we can put a poster up or something. And we saw our mobile freezers, and then Dr. Kathy Ramirez Aguilar was like, wait, that was given to y'all like 3 years ago. We thought we lost it. And the lab was understanding. They were like, oh, we just completely forgot we had it. But again, communication, most of our labs are nice and kind enough to remind us like, okay, yes, this is yours, like here it is. And if it ever comes down to like, sticklers that don't want to move out of our freezers, we always just talk to the building manager. We talk to other labs that could potentially help them out, since our -20 freezers are for, 1 to 2 week use only. But again, always about communication for us.
Awesome. Thanks so much for elaborating on that.
Yeah.
I'm going to turn back to, so if anyone has more questions that they want to pop into the Q&A box, please feel free. I have a couple more questions myself for our lovely speakers today. I guess, Phil, let's go back to you. So what's the best way for labs to find out if there are midstream rebate programs available in their state or their city? Is Energy Solutions the website to go to learn more about that? Are there other places where people can learn more about how they can take advantage of those? Oh, and you're muted, Phil. Sorry.
Absolutely. I can go ahead and share actually, do I have a way to share this in the Q&A? I can post this a link where it's
to everyone in the chat now.
Okay.
So I think everyone who's on the webinar can see the chat for things that we post to everyone.
Excellent. Well, it's energy-solution.com/life-science-programs. But I'll paste that one, and there you get an interactive map that shows where in the US these programs are all available for midstream. You can also ask your supplier. It's a great conversation to have with them, especially if you're in California, Washington, Idaho, Wisconsin, Michigan, New York, New Hampshire, Massachusetts, or Rhode Island. And if not, if you're in another state or you're in a region that may not necessarily be covered by one of these programs, since they do they can vary from each individual utility to individual utility. You also can check your utility's website or reach out to your utility rep, because if any large institution, they should have like a key account manager that works with someone in your facilities group that you should be able to connect with, especially for any large projects or anything like this. And one of the other cool things is, I know it was mentioned that CU Boulder has their own incentive programs, which is awesome. If your local institution does have their own incentive program, and there's a separate incentive program that your utility is offering, you can stack them. The only time you can't stack them if it would be like, say, two that are both funded by the same utility.
Great, good point. And yeah, I know the incentive program at CU Boulder has been in place for a long time, and that's been really popular. It's not just for freezers, for energy and water efficient equipment. And so if any of you that are on the call have, connections to your own facilities department at your organization or the operations team, whoever's paying the energy and utility bills, I encourage you to reach out to see if you can implement something similar in that same vein, because those groups that are paying the bills might be really interested in that if you haven't explored that avenue yet. All right, so we have another question that came in from Amrita. If freezers are not full of samples, for example, if we have half of a freezer full with empty space or half of a freezer with available empty space without racks, what do you fill the freezer with? Are ice packs a good idea? Another alternative? So I think Leoncio and Emily have addressed this in the chat, but let's verbalize that.
Yeah, Emily, do you want to go first?
I can go first. I often like to recommend labs share freezer space with other labs if possible. I always love when labs share or interact with each other. Of course, some labs aren't willing to share, and so I like to see typically a lab that only has half a freezer full has more than one freezer. So I like to see if they can condense all their samples into at least 1 or 2 freezers so that they have at least one empty one, and then have that freezer turned off in the time being. Sometimes labs are a little hesitant to turn off a freezer because they're like, well, what if I need it? What if there's an emergency? And so in that case, I like to tell them, well, you can set it to -60. That's going to save a lot of energy. And it will also make sure that if you need it in an emergency, you can change the set point and it should get back up to temp fairly quickly.
That is an excellent example, Emily. I might take that from you. I think also, for example, if a freezer or in a lab, if they're having like at least the bottom half of their freezer underutilized for an extended period of time, I think what what you just said, Emily, is a great idea. If it's like temporary for like a couple days or a week or so, I typically add some dry ice, some small quantities of dry ice to the freezer, or I also just add normal ice to the freezer. You can also just add empty freezer racks to then keep the temperature consistent. I don't know the physics behind like the volume of air versus like adding like freezer content like metal into the freezer. But for us, it's been working where we've added like empty freezer racks and it maintains the temperature at a consistent rate. I don't know if that's also something y'all can use, but that's what we do.
Just be careful about dry iced in enclosed spaces, because it can, it's subliming there, off gassing. So perfect. Thank you both for addressing that. Leoncio, so the shared freezer program I know has grown over the years, and I assume since you've added more freezers since I was at CU Boulder, it's a popular program. Like, are all the freezers at capacity? Do you try and always have them at capacity, or is there space in some of them still if people want to take advantage of that? How popular is the program?
Yeah, so our main campus freezers are super popular. Our East Campus freezers are as well. to the point of like having to just talk about getting new freezers almost what seems like almost every semester. So yeah, right now we reached out last year to a lab over in the engineering center that was interested in using the incentive program to purchase a freezer for their lab. However, they reached out saying that they rarely use more than a shelf of space. So we actually collaborated with that faculty member to create their freezer into a shared ultra low. So now they're part of our program, which made it the 8th freezer.
Great.
Yeah, I think overall the freezer program is just continuing and it's growing. I'm super happy and glad that our freezer team, which is full of undergraduate and graduate students, are helping up with the operations, whether doing outreach or cleaning the freezer. If it ever comes to like, hey, we have this new freezer that no one's using, we always try to do lab to lab outreach, making sure that people are aware that this resource is available to them. Because most of the time it's like that under-informed status, right? Of like not knowing what resources are on your campus in the first place. So having our students do lab to lab outreach or putting signage on their TV screens and monitors in the research building, I think it's a great way. Some of y'all might know this. We have some of our signage, our Green Lab signage in restrooms, like above the stalls and behind the and above the urinals. And so we, in research buildings, put some of that signage up there saying, hey, we have these resources for y'all. Come learn more about it and use them. So luckily right now, most of our ULTs are utilized. However, we always have folks moving in, moving out. So right now we're in a good routine of implementing folks into our freezers.
Amazing. And how often are the Green Lab student assistants checking those inventories in the shared freezers? Is that quarterly when the billing's happening, or is it happening more frequently?
Great question. So because the program was growing, I created a subgroup for the students within the Green Labs program. So right now I have about 1 graduate student within the freezer program team. What we do is that we check at least once a month a freezer. So if we're doing the engineering center freezer, for example, and we need to check inventory, I assign them to go do inventory checks into that freezer at least once a month. And then if I frequently walk around and check freezers occasionally. And if I see like one freezer is not aligning with the inventory spreadsheet, I assign that freezer. So typically I would say 2 freezers a month, but I try to get to every single freezer a semester. We also do bi-weekly check-ins with the freezer team to make sure that all of our inventory and our billing spreadsheets are up to date. And then we connect with our procurement officers and let them know that, hey, this is what's going on these 3 months. We're ready for the quarterly billing, and then we get situated with accounting. So everything gets checked at least once a month, if not more.
Great, thank you. Emily, I have another, I guess we're almost at time. I have a quick question though, like maybe this will be the last one to wrap up. Has the freezer, you've mentioned that the freezer maintenance program is popular and, people like that they don't have to schedule it, you just come around. How has that led to further support of the UAB Green Labs program? Has it allowed for additional support in any capacity to other efforts within the Green Labs program?
Yeah, we're able to take, because of the freezer challenge, it gives you an estimated kilowatt hour savings per year. And they also give us all of our lab savings all at once. And so we're able to give that to upper administration, show them this is how much Green Lab saves in estimated energy. Here's how much we pay per kilowatt hour. Here's our estimated energy savings. And so it really puts some teeth behind our program, showing, hey, we actually do save money as well. We're also able to really interact with the labs a lot more and ask them what they are needing. And the freezer challenge does such a fantastic job of kind of showing us where we are missing things. One thing that I learned in this freezer challenge is a lot of our labs seemingly don't have racks inside their freezers. I just wrongly assumed that our labs had racks and weren't just throwing sample boxes in our freezers. And this challenge, I learned that that is not the case. And so this year we're going to be doing a push of identifying unused racks, giving those to labs who need racks, and then trying to tell people to maybe put their samples on racks, that it might help keep them a little more organized.
Yes, that has been a fascinating thing for me to learn as well as part of leading the International Laboratory Freezer Challenge. Well, I want to thank Emily and Phil and Leoncio once again for being a part of this freezer forum. Thank you so much for giving us your presentations and sharing your knowledge with us. And I'm going to turn it over to Kathleen to wrap up.
Yes, thank you so much for moderating, Christina. You did a great job. And to our three speakers for your super helpful tips. I mean, especially ways to make these efforts cost effective, whether it's getting some incentive programs or using student labor wherever you can. And these lessons learned that, you know, tips for just going around and cleaning filters and stuff, Emily, were fantastic. And, you know, sharing resources, all these things are good ways to get these efforts done without using too much funds, which I know are limited. So thanks to everybody for participating today. We will have continue our forum, our roundtables regarding circular economy topics in the future. We'll be talking about green chemistry, and ice packs came up. So that's something that we're probably going to tackle once the weather gets colder. And we will probably take a month or two off since we're focusing on our conference. As you can see here, it's coming up right at the end of September and into October, and My Green Labs Summit in a couple of weeks. So we hope to see you all there, and thank you to everybody.